Hi, I'm Joe, and I'm here with our master of validators at Parity, Will, and we're going to walk you through how to get a validator set up on Polkadot.
So some of the things that I'm going to touch on is how to run a node, how to kind of set up the accounts that you would need to run a node, what actually kind of running a node means, things around kind of the keys involved, things around kind of going from keys to running this node to actually seeing this happen in the UI and seeing it actually work and all that kind of stuff. So just to kind of start, there's a good kind of starting point workshop type GitHub repo that is worth checking out. So this is at like vPank. This is my GitHub trustless validator workshop. This is kind of just a repurposed GitHub repo that was also for a previous validator workshop, but this will work just as well. You can download all of the files that we're mentioning from here, and there's also kind of a README here that should describe these things as well. So just to kind of start with the actual like the process that's involved, I'm just going to start this now because this may take a second, and then going to kind of talk about it and work through some stuff. So just going to start some Terraform things. We will explain what that actually means in a bit. This is downloading the Google plugin that Terraform will need, and then can start talking about kind of like what actually validating on Polkadot is, what that means, kind of how it's different from other different validating proof of stake type networks, I guess.
Yeah, so like first of all, like how we select our validator set is a little bit different. So we use nominated proof of stake with this algorithm that's called sequential fragment. And basically, like instead of other proof of stake networks where you might need like X amount of whatever token in order to be a validator, or you delegate to people like some networks, you can say, you know, I'm going to give 20 tokens to this validator and 50 tokens to this other validator. What you do in Polkadot is you just say, I have, 100 tokens that I want to bond. And then here's a list of validators that I find acceptable, that I want to nominate. And then this algorithm fragment will actually figure out how to optimize your distribution, which helps the network keep like a really evenly staked validator set. And it will also end up giving you the best rewards. And the reason that is that like, instead of giving validators rewards based on how much they have at stake behind them, we do rewards based on activity. So like block production, finality justifications, parachain attestations. And so the reward of a validator has nothing to do with how much stake is behind it. So you'll actually get more rewards if you're nominating a validator that has less at stake. And so this fragment system is going to like distribute your stake more evenly across the validator set, which is good for network security and also good for the nominators. And then like from a validator like operation standpoint, one of the things that's different is that we have a lot of signing keys. So most networks, they might have like one validator signing key, and in Polkadot we have 5, but it's also like in the runtime, so we could upgrade this and actually change the number. So yeah, I guess we can like go through some of those keys. So we have a babe key, which we use for the VRF for like assigning block production rights. And then we have grandpa, which is for finality. And then authority discovery, which is not as fun as a grandpa or babe, but like this helps the authorities discover each other so they can kind of broadcast to each other, hey, these are my sentry nodes. This is where to find me in the network. We have I'm online, which is we use this for sending heartbeats to let people know that you're online. The primary way is by like authoring blocks, because if you're authoring blocks, then you're obviously online. But since the block authorship is random, then just in case you randomly don't get selected for a long period, you can send this heartbeat message that says you're online. And then the fifth one is this parachain ID that you'll use to assign attestations to parachain availability and validity. So those are the main things. And then I guess we can go back to this Terraform script that's running and talk about what it's doing.
Yeah, so just to maybe take a step back and describe some like what the overall architecture of these things may look like. So in general, compared to the previous types of like what mining and whatnot looked like people used to have kind of like GPUs, things like that. They would run them in these big data warehouses and whatnot for like Ethereum and Bitcoin and things like this. Proof of stake is generally better because you can just run this on more or less like any type of cloud server. And so that's actually what we're going to be doing. So generally you'll have multiple kinds of nodes. You'll have kind of like your actual validator node and then like sentry nodes. Sentry nodes are kind of these nodes that are exposed to the public internet. Generally, you don't want the actual validator node itself to be exposed to the internet because it can be DDoSed, and that's kind of it can lead to a loss of funds if exploited. And so you generally will have kind of this validator node, which is behind a firewall and VPN and those types of things that are then connected to sentry nodes. Sentry nodes are then exposed to the public internet. But in general, these are just all kind of nodes that you configure. That like the actual node is the same. You just configure them a bit differently. Today, this was just going to be walking through only just the validator node itself. In general, you should take a lot of precaution to determine like security, like how much access this has to other resources and things like that. But that's not going to be covered here. This is just kind of just walking through going from one validator node and setting that up. So, okay, what is Terraform? Terraform is part of this kind of infrastructure as code type DevOps tooling set. So in general, Terraform is kind of a very declarative, descriptive way to actually describe your infrastructure. So what you'll do with Terraform is actually describe kind of what your host in the cloud will look like in a very like declarative way. The alternative in like previous way that people used to do this was just kind of go through the UI of say like Google Cloud Platform and like manually click through the menus and be like, hey, I'm gonna provision this new like server that has this amount of memory and this CPU and those types of things. Like Terraform in general, you kind of can create these like reproducible builds, and it's useful for just automating things that you can just run a simple script for. So to walk you through kind of the main script here for Terraform, that's this kind of main.tf file. Here you're just kind of describing a lot of the things for the server that's going to be provisioned. So first is kind of this Google provider here. And for this, you'll need to kind of set up the credentials part of from Google Cloud. And so that is kind of described here. So after you kind of create a account on Google Cloud, and then you create a project, and then you create kind of a service key, you're going to actually rename that service key to credentials.json. And that's kind of what this is here. All these things are variables, and so variables you can just easily describe kind of what the actual variable you're storing is, and kind of in this variables file it will have a description of what that is used, what it is, and what it's like used for. Some things are already kind of pre-filled in here, and some things would need to be filled in yourself. So, for example, this main thing here is kind of describing the service key. That's kind of this credentials.json that just described. Project, this is the project name that you'll set up when you create the project. Region and zone, these are kind of where it's actually being set up. So I believe this is US like West 1. Resource random ID, this is kind of just to differentiate between the actual kind of resources that you create in Terraform. This here you're creating a static IP address so that you could have it be referenced later in a static manner. And then here is describing the actual like machine that you're going to provision. So this is naming it with Kusama dash, the actual that like random ID that I just mentioned, machine type. So here this is kind of a N1 standard 8. This is a super like beefy machine that is probably overkill in a lot of ways. This is like an 8-core, 32 gigs of RAM. Not what you need. I'm just using this for demonstration purposes because it is a bit faster. Generally, like N1 Standard 2 is kind of the one that should probably be used. That one is a dual core 8 gigabytes of RAM, and that's kind of like standard, like what would probably be used here. So like the minimum specs would probably be dual core 8 gigabytes of RAM and 100 gigabytes of memory. So for storage. Generally, like the actual like chain state is not that big, but like logs can take up a lot of memory in the future, and so having that much of storage is useful. The actual like OS here, like using Ubuntu 18.04 is one like option. CentOS and like other like Linux distributions are others, but Ubuntu is generally pretty good. And then here describing like the SSH keys. So in order to access this VM, you need to generate SSH keys and then reference them. So in this like scripts folder, there's this like generate SSH function here that actually creates these SSH keys. Let's see here. So what this was running before was kind of this this process of actually creating the VM, and then I believe what this error was just saying was that like it couldn't actually download the database that it was referencing, which is fine. So like the way that like this has been working so far is you'll provision the VM and then you'll like transfer a file, like just a script, and then you'll run that script, and what that script does is download Docker, download the like database to the VM or to the Kusama chain, and then start the node like from that chain there. So just gonna try running this again. This will actually, I hope, actually finish. Sometimes it's like non-deterministic if so like right here was where that didn't actually finish, was that the database didn't like finish downloading, and so it cut off the tape archive, and so that didn't finish. But to kind of like walk through some other parts of this, there's kind of this setup script file here, and so there's a couple of parts of this. One is kind of just installing Docker. That's kind of one of the main ways that you can run a binary for this. So there's, I would say, like 3 different ways of actually running a Polkadot node. One is actually downloading the source code and then compiling it yourself. This generally may take like a half hour or longer depending on your machine. And then another way is running it in a Docker image, which is kind of what this is going to be doing here. And then a third way is just looking at the releases and downloading the binary from GitHub. What this is doing here is kind of just downloading Docker. If there's kind of like an external database set, it'll download that, create like the database folder, unzip this like tape archive, and then put it in there, and then you could start the chain from pretty close to where the actual current point in time is. And then creating like a system daemon here. So in general, like on these servers, like running this as a system daemon is pretty useful, mostly just because like it can easily restart. You can like look at logs, things like that. So here, running this as a Docker container, naming it Kusama validator, is part of kind of Docker exposing some ports from inside the Docker container to outside the Docker container. So 30333 is the peer-to-peer port. So this is what like people will talk to, like the libp2p networking layer will communicate on. And then here is the RPC port. Here you're mounting the volume from inside the Docker container to outside of it. And then here's the actual Docker image that we are pulling. So every release gets like automated to the Parity Docker hub. So Parity Polkadot latest is the generally like the most recent ones. And so this Docker container here is generally just like the binary. And so running this is you're running the binary with these are all the flags that you would then run like a node with. So -- validator is saying that this is going to be a validator node. An alternative to this would be maybe saying like -- sentry node, which is kind of this sentry thing that I mentioned earlier. -- name, this is the name that will appear on telemetry. And then -- pruning archive is something that you will need for validator nodes just because you need like the entire state. And then WASM execution, the options here are either like native or compiled. Compiled is generally faster for kind of syncing from the start. And just in general, it depends on how things are, like WASM blobs are processed, I believe. Is that right?
It's like interpreted versus compiled. So for the older runtimes when you're syncing, you don't have like the native runtime, so you have to run it through WASM. And then, yeah, you have the choice of either running it through an interpreter or running it through an AOT compiler and executing it that way. So it's going to be quite a bit faster using the compiled. I think it's like 7 or 8 times faster.
Yep. And generally, like running it in compiled will give you like 100 plus blocks per second when syncing, which is generally a lot faster.
Yeah.
So also here is kind of like you're just kind of putting this into a service and then enabling that service. And then afterwards, this is one of the commands that will be needed to actually start the validator. So depending on how you're actually running the node, you can just kind of send a curl command from inside of it. But because this is in a Docker container, and because of the way that the ports are exposed, you need to run this from inside of it instead of just from the cloud VM. So this is going to send this author rotate keys RPC call. And this is going to send this to localhost because this is where the node should be running.
Yeah, and so this will give like an output of all 5 of these session keys. Like they're all like a private public key pair. So it'll give you the public key, which we're actually going to submit in an extrinsic on chain, so that the chain knows like which validator is associated with your main like your funds account.
Mm-hmm. And so running this here is actually to scroll up a little bit here. Like creating the actual image itself, or creating the cloud VM, and then this remote execution here is transferring the file, this setup file here, and then actually going to execute it. And so right here, all these kind of logs there are. This is the large kind of just time sync of this script here is actually just downloading this the chain data. And currently this is like 17 minutes. This isn't like super necessary.
In order to have an account, you need to have, well, in order to run a validator, you need to have 2 accounts. So you need to have a stash account, which is where your funds are, and then a controller account, which submits like your preferences. So like if you want to take a commission, or like change your session keys or anything like that. So that lets you keep your actual funds in a separate account. And so we're just going to use this tool called signer-cli. It comes with Polkadot.js. And so this lets you submit transactions or generate and submit transactions offline. So I have a couple accounts to work with here. So I have one, this demo stash, has 5 KSM, has 0 transactions. So I've never done anything with this account before. And then I have this other account, also 0 transactions, with just a little bit of KSM in it that I'm going to use as my controller. So using the signer-cli, so I'm running a node here that I'm going to submit this transaction over. But I can run this, signer submit. I'm sending it from the stash account to my local node, and it's going to ask for like all the chains metadata and everything. So it knows what functions, and I can call like any function here. So I could call like balances.transfer, whatever, and then put the parameters here. So this gives me a payload to sign. So I'm going to take that over and I'm going to sign it with the same tool, and it's yarn run signer sign. I'm setting it from this account with this seed here to give it a type, and then I'm just going to put this payload in, and this will sign it. So it gives me a signature, and bring it back over here, and this will actually submit the transaction over my node. So this should actually give me here, it has one transaction, a little bit less than 5 KSM now because I paid a transaction fee, but it has this as a controller account here. So now when I go over to the staking tab here, staking account actions, you see that I have a controller account here. So there's demo stash, demo controller. This gives me some options. So I can change the reward destination. So before I set it to controller, I could change it and say, actually, I want to send it to the stash account and increase the amount at stake. But not going to do that for now. I can also nominate, or I can set session keys. So we need to do that before we can validate. So that's what we're going to do now.
So here, this is sending that RPC request, and then this returns the result. So here, this JSON RPC result, here is what you will then copy and then paste into the UI to actually set the session keys.
Yeah, so we take this, and so this is the stuff this is the session keys that are generated for this node. So we want to link this actual node to this account. And so we do that with the session key. And so this goes into here. We're going to set this, submit a transaction. And so yeah, so that's the session keys for this account. And now you see we actually have a validate option, so we can either nominate or validate with this. So we're going to validate, and then let's set like a 2% commission. Validate. And that's it. And so now we should actually be in this this waiting queue. Yeah, here we are. This is demo stash. So that's us waiting to validate. So that's pretty much it. And then this is still your controller, so you can still change your reward destination or change your session keys. Anything else you want to add?
And then just kind of one other thing that I would add on to this. So what happens then kind of when a new version of the substrate node comes out and you want to upgrade, what you would do then is actually do this kind of same process and then spin up a new node and then call this rotate keys again, while still having your current node running. And then do pretty much the same process of copying the result of that new node into that, and then setting the session key again. And then once the error changes, this new node should be up and running, and then you could safely take the previous node down. And so that's more or less the way that you would upgrade nodes. So yeah.
Yeah. And so anything else, or is that all there is to it?
I think that's pretty much it. So,
all right.
Yeah.
Cool.
Thanks.